Okay, so this is the second part for the chapter 25. We're gonna do the exercise number 12. It still relates to the scuba diver, and the question is, given that the angle, the ray in the water and the perpendicular to the water is 25 degrees, and using what we found already in the first part, find the height of the instructor's head above the water, meaning where is the head from the water. Noting that you will first have to calculate the angle of refraction, which we already did. So in order to simplify this problem, let's imagine this. I'm going to redraw this diagram this way. Here's the water. Here's the person out of the water. Okay. And what we know is that from the vertical, okay, the diver hit here and then goes up here. Okay, so that's the light, the ray of light from the diver into the person. What do we want is this H height here, the head above the water. Okay. We also know from the previous problem that the person is at 2 meters from the vertical. Okay. Actually, this was like here. Sorry. Okay. So think about this. We have a triangle. We already know what this angle here is, right? So we have this distance, 2 meters. We want the height and we have the angle. So if I'm drawing this triangle here, I have the head, I have, this is my triangle, where this is H, this is the distance 2 meters, and I have the angle, which is, we found it was 34.3. Okay, so this is a geometry problem, and so how do we find it? Well, the tangent, okay, of this angle of 34.3 degrees is equal to, okay, what? D over H. Okay. And so H is equal to D over the tangent of 34.3 degrees. D is 2 meters. Okay, so I'm just gonna change this one here. Divided by that number, we got 2.93 meters. Okay? The second part of this question is find the apparent depth of the diver head below water as seen by the instructor, assuming that the diver and the diver's image are the same horizontal distance from the normal. What does it mean? We go back to this diagram here. The ray of light that comes from the diver hit the water and gets distorted. Okay? Which means that the person outside sees the diver from a different position. I mark it here in blue. I hope you can see that. But if you cannot, imagine that the light comes from the diver, from the person outside, and goes straight here. Okay? What it says is that the image from the diver appears to be a little bit above. And this caveat here says assume the diver and the diver side image are at the same horizontal distance from the normal, which means that the distance from the normal is the same for both the real diver as well as the image over there. So let's redraw this diagram in a little bit more clear fashion that will help us understanding what is going on here. So I am gonna erase this part here so I have a little bit more space, and I'm gonna use this space here to draw that diagram, okay? So what do we know now is that I have a, let me draw the vertical line, okay? Here's where the diver is, okay? And here is where the diver looks like, okay? So how many angles do we have? Well, we already have this angle over here, which for now I'm going to call theta 2, okay? And then we have this other angle over here, which is the one that we will need eventually, which we call theta 1, okay? So again, theta 2 is the angle between the real head of the diver and the vertical. Theta 1 is the angle between where the head looks like and the vertical, okay? Again, the vertical. So the depth of the real diver over here, we call it little d, and this distance from the vertical, we call it y, okay? What do we want is the actual height or depth underneath the water of the image of the diver, okay? So you see we have one triangle, which is dy and that, where we have the angle theta 2. So I can already write that the tangent of theta 2 has to be equal to y over d, okay? And then the tangent of theta 1 is what? Well, is the depth over there divided by the distance, which is equal to this one over here. And so it's y over x. Okay? Now I can match these two because I have y in both of them. Okay? And so we can divide one on top of the other. And so let's see what I get. I get the tangent of theta 2 divided by the tangent of theta 1 equal to y over d over y over x. Okay? So here you have to play a little bit of algebra, and you find out that the tangent of theta 2 divided by the tangent of theta 1 is equal to x over d. Make sure you do your algebra right, check this, okay? And so we want x, and so this is the depth of the diver times the tangent of theta 2 divided by the tangent of theta 1. Okay, so do I have theta 2? Yes, theta 2 is my original 25 degrees. Do I have theta 1? Well, let's see. This one here the angle here is exactly this angle over here, which is the refracted angle over there. And so theta 1 is 34.3 degrees. And so when you plug in these numbers, in these equations, you have 1.37 meter. Remember, D is the depth of the diver and was given 2 meters. Okay? All right. So I'm going to stop this one here.